So thanks for joining the session. So myself Ganesh. So I have been into the software engineering, systems engineering earlier, and later I was into the data science, NLP engineering, the machine learning, and currently have been working into generative AI. So I have more than 2 years of experience into the AI and software engineering. So basically, I will be working as the full-time employee, but this is like just the free time. I would like to dedicate some time to teaching. Okay, so yeah, so I have worked into the various organizations, let's say the IoT, telecom, and the retail sectors. So primarily, I'm currently working as an individual contributor, handling the end-to-end of the projects. All right, so that is all about me, but this session primarily focused on the AI and generative AI. So I'd like to give a brief about what is an AI and generative AI and what I will be teaching and during the entire the course. Okay, some of you may be already aware of it. It's kind of a uh, most of the people whoever joined here are very beginner to the AI, as for my understanding. Okay, a few people may be already having the basic knowledge, but may not be the full-fledged knowledge into the deep learning, NLP, and generative AI. Okay, so let's just make this the session interactive. So you can ask me any doubt in between. So we have till the 9 p.m. I'm basically from the Bangalore. So it is from the 8 p.m. to 9 p.m. the session. Maybe next 50 minutes we'll be continuing. After that, I had to jump into the another session. All right. So yeah, so let's start it. So I would like to ask a few questions so that I can test your knowledge. What is your background about the AI? What do you think about it? And what kind of a jobs you are looking for, etc. So we have total 7 members here, as I can see. So all right. So can anybody tell me what is the AI and generative AI? So what is your basic knowledge? It's okay even if it is wrong. So just make this session interactive. Yes. Anybody? Anybody? Just take it up. Just speak it out. Like, what do you know about this?
So what's the question? Sorry, come again, please.
Am I audible?
Hello?
Hello? Am I audible?
Yeah.
Yeah,
Hello?
just tell me because you're audible, I know. Because in case if you see any discrepancy in the audio, let me know immediately. Mani, I think you're facing an issue.
No, no, I'm good. I'm good. I'm just asking, like, what is your exact question? So it's a
Question is the
this,
question is I'm asking what is AI and generative AI? What do you know about it?
hmm. I know between A generative A is something, A is kind of a static and the generative A is something like which is dynamic.
Mhm.
That's a difference. In a one line word, I can say that.
I see. So can you tell me few applications you're aware of it? Like because you told like the static and dynamic, that is more of like do you think the AI systems will run without any? What is the definition of static and dynamic?
So basically, static is kind of what it's a limited scope that it has
Mhm.
in the AI.
Mhm.
Static or generative AI is something which I don't know like how to explain. I think it's generative AI is something that you it doesn't have a like it have a capability of searching searching an optimization more and then it gives you more
Right.
output.
Okay. All right. So let
Yeah.
me let me let me
Basically tried basically.
mm,
Okay, sure. Yeah, go ahead.
yeah, fine. So the thing is, so let's back to the classical machine learning. How the machine learning concept has come, and then how it is evolved with deep learning, and then now generative AI. You will be able to see, right? So I'll just start from the classical machine learning. What is happening over there? What is the training? What is the model? What kind of algorithms were there in the machine learning? How we jumped over to the deep learning and subsequently with the generative AI. You're able to see my screen, right? I hope so. So you're able to see
Yes,
my
sir.
screen? Yeah. Thank you for
Yes.
Yes.
confirmation. So given A comma B, okay, so this is my input data given to you. So let me Right. Just look into this data. Can you tell me what will be these numbers which was written in the question mark? What will be these numbers? Just look into this data. It's kind of an aptitude. So given a comma b as two columns, I want you to see it and find what could be these two numbers. Just guess it. Whatever the approach you are going through it, it's fine.
Seems like it doesn't follow any particular pattern, but could be 17 and 18.
It's 17 and 18. So any
Yeah, yeah, maybe
pattern
it's
you're
it's
matching?
like a yeah,
Mhm.
it's like a two sets of sequential numbers.
Okay. Some sequential number. Okay, some sequence you are following as the order,
Yes,
saying like maybe
yes.
17 and 18. Somebody replied like 18 and 20. All right. So everybody's looking for the pattern, right? Historical data was present. Maybe the 2 to 10. This is your input data given to you, and everybody started looking for the pattern. So what kind of a permutations and combination you're trying it out? So randomly you're looking out. So is there any pattern you're able to find? So ultimately you are trying to find a function in terms of the pattern, isn't it? So maybe one of your pattern may be the somebody 18 and 20. Can you tell me how it is 18 and 20? Somebody replied 18 and 20. So what is your
Oh,
pattern?
I thought from row 8, you're doing 7 twos 14, 8 twos 16 minus 1, 9 twos 18 minus 2. I thought like 10 twos 20 minus 3. So it should be 17. And 11 twos 22 minus 4 18. So
Okay.
irrespective of what number we have on B, I thought 2 is the.
Yes. So that is what is happening entire the AI. So in the classical machine learning, so given the data, this is the input data A comma B. So this is output data, the result. So in the previously, you try to understand the pattern. So the idea is history repeats. So in that process, whatever the function you get in terms of this thing, and that function you try to evaluate. So here, the data which you use to find the pattern, we call it as the training data. We call it as the training data, and the data which you use it for the testing. Suppose you found the pattern here during the training process. So you're trying for the every single pattern, you found some pattern, and that pattern you try to apply it on this testing data. So this is my testing data. So then we'll understand, okay, if this is correct. Of course, we should know the ground truths. What will be the exact value for this thing? Maybe the x and y, let us say. So we know the exact the ground truth values, and you apply this formula into this one. If it is equal to the x and y, whatever we have, so we can say that our model is correct. After the training, you get a model as an output. So for here, the answers are the 17 and the 22. So here the pattern is 2 multiplied with a minus b plus 2. Of course, if you could have spent some more time, maybe 5 to 10 minutes, you could have find this pattern. Because the training time may be larger because your brain has to process the input, right? Then after some time, you may be able to find the same pattern. So the idea is your machine, the algorithm, whatever you choose to find the pattern is will define in the mathematics. So how do you find this pattern? 2a minus b plus 2. So there will be algorithms will be there. So because it's a statistical modeling, because predictive modeling, so where you have the input and output, and algorithms, we have the multiple algorithms into the classical machine learning. So we segregate the algorithms into the supervised and unsupervised. So what's supervised? The supervised, we have the input as well as an output. We're trying to find the pattern. Okay, so input should be there and output also should be there. Input we call it as an X, output we call it as a Y. So in that again, we have the two levels. The what is the result? Result, is it a number or is it a categorical variable? If it is a number, we call it as a regression problem. If it is a category, we call it as a classification problem. So what do you mean? For example, you are trying to predict the weather. What will be the weather in next 1 hour or entire day? The temperature prediction, right? Enter the whether the temperature is in the number. We call it as a regression problem. Suppose, given a same data, you have to predict whether will it rain or not. Yes or no kind of a question. That we call it as a classification. So can you give some examples for the regression classification in day-to-day lives? Just think about it, whatever you could. Just give me some examples for the regression as well as classification. You have to
I could
predict
think of
something.
I
Yeah,
could
tell me.
think of classifying spam emails and the non-spam
Excellent.
emails.
That is very good. Very good example. The classifying the email as a spam or ham, right? Spam or not. It's a binary because given an email, entire email was given, and you have to predict whether it is spam or not. That's a very good question answer. Yeah, classification of the email. And any other thing for the regression?
House price predictions.
Yeah, very good. House price prediction is nice.
Yeah,
And what else? Stock market prediction. Can I say?
yeah, stock market. Yes, correct.
Um, and this is like email spam or ham. All right. So then what else? Yeah. So there can be, suppose given a record of a patient, whether the person is diabetic or not, or given whatever the income and household information of a data, and you would like to predict whether the person falls under the below the economy, the poor, or middle, or the rich, or super rich, maybe some particular variables. So the first one here is a binary classification. You only have the two variables, diabetic or not, spam or not, whether the person is having cancer or not. Or here, you can see the multiple variables, right? We call it as a multi-class classification. The first two are binary class classifications. This is a multi-class classification. And the remaining regression will have only one. So because you have to practice the continuous variable is a number. So what is unsupervised? If I remove this in output data completely, only I have given to you the input, then I want you to do something. I don't know what you will do. I want you to do something insights which will be helpful for me. So that is the unsupervised learning. In the unsupervised learning, we don't have the output data. We only have the input and you have to do something. Can you think of some such kind of an examples? Can you think of such kind of an examples where no output data was given to you, but you have to predict what will be the some insights. Some insight you have to get it.
Customer segmentation.
Very customer segmentation is excellent answer. So given a bunch of customers, suppose you are running a company and so you're selling some product, you have multiple variants of the customer, like Amazon will have multiple customers, right? In that, can you segregate the customers into multiple clusters? So you segregate it, maybe the cluster number one, cluster number two, cluster number three. Suppose you have given a value of K. K is nothing number of cluster. Given a customer data, segregate into three. So then you look into it. Okay, C1, what is it? Maybe this is low income people. This is like the average income people. This is like the high income people. This intuition you have to do manually. The algorithm will not give you. It will segregate only the segregation it will do. Okay, go into the cluster one. How many customers are there? What is their behavior? And you have to manually look and then you have to figure it out. Okay, I can see all these cluster people are having the low income people. So can I call it as a low income? Maybe in the cluster 2 is having the income range a little bit higher than the C1. Cluster 3 having the more income. This will help the customer company to do the marketing. Why? Because this I know these clusters. Okay, so my goal is to attract the customers or apply some offers. Suppose this high category customers are there, so I can do the cross selling to them. Suppose I can do the email marketing or the call to them and okay, tell them okay, these are the offers I can have. You come and buy something because the okay, look, maybe they may not be buying much much things. So then this will help us to do the marketing. So the unsupervised learning, the good example is the clustering. So this is what has been happening in the classical machine learning earlier. Of course, we have the different algorithms for regression and classification. Suppose linear regression. So the um, then wait, linear regression and the decision trees and support vector machines, random forests, boostings. So many things you can use for the regression. And similar to the classification, we have the logistic regression. Logistic regression, not a regression, it's a classification. So, and you can use the same decision trees, the random forest, and the SVMs, and the boostings, gradient boosting, or the XG boosting. We have multiple algorithms. Some algorithm, we can use it for both of them by just little bit tweaking. Okay, so this kind of algorithm, we train with the data, whatever we have, and we get a model. That model will be able to predict our output. Model is nothing but it will have some pattern, whatever it's showing here. Each and everything will have its own mathematics behind it. Yeah. So after moving from here, so what is the programming you had to do in this? Where the programming comes into the picture. First program, what is the entire life cycle? First, you have to have this data first. If you don't have the data, you can't do any training, right? How do you get the data first thing? First, you have to do data gathering, or I can call it a data collection. You can get from the database or public APIs or scraping, anything you can do. Once you got the data, do the data pre-processing. It should be suitable for the training. You have to do all the techniques to do the pre-processing. And then you do the feature extraction. What are the features? Here, you look at the A comma B. Each column is a feature. So I will tell you, maybe it can be the age of a person, it could be income of a person, it could be like gender. So it can be anything in the column. Then you train the model and test the model. Then it is okay. Model deploy it. So this is the entire life cycle of a the machine learning. Okay. So let me open a PPT. Just a second. So look at here, the data preparation. So what kind of a data can be there? So far I have shown you only the tabular data. What else can be possible? So data can be possible in multiple ways, right? Total, how many ways the data you can see generally in day-to-day life. So data can be in the tabular format, nothing but structured format. And data can be images. Data can be text. Is it right? The images are
Yeah,
videos because videos or images both the
Ganesh,
same, right? Yeah, hello.
sorry, this is Baji. You said table data can be a structured format. Can it also be an unstructured format as well?
Yeah, what is unstructured? Because this is unstructured, right? Text is unstructured.
Okay.
Yeah.
So the
So the
data point, that's something that, okay.
so the
So we
unstructured is
have a
nothing but
raw data
text.
that is not structured. So what I meant is we have a raw data that's not structured. We have an objects with different metrics, different values. Let's say we have hundreds of
Maybe
objects,
it is a semi-structured.
right?
Is it a JSON format?
Okay.
Maybe it can be
Yeah, it can be
semi-structured, right?
JSON, it can be HTML, yeah, anything, yeah.
Yeah. So the thing is, you have to make it structured. So we have to use the techniques. That's why I told here data pre-processing, right? You collect the data, so you have to make it suitable for the model training. If it is predictive modeling, you have to make it structured in this format. Okay. So otherwise we can't train it, right? So we have to, if it is a tabular form, eventually you have to make it into the tabular format if it is a this kind of a data was there for the both classification or regression. So images and videos, you don't need to do anything because you already have the images. Text also, like it will be bunch of words or sentences, right? Or paragraphs. So if something value was there, key and value kind of appears. So we had to convert into such kind of a format, and then only we had to do the training. right? Yeah. So coming back here, so the data can be into the multiple formats, feature extraction step. So what is features? Because as I told you, see, if the tabular data columns are the features. So what are the features if it is image data? What are the features if it is image data? Given images of the dog or cat. So I would like you to build the model which can segregate or identify the image, whether it is a cat or dog. So give this the image to the model. So what is the image? Image is nothing but pixels, right? It will have the values of the pixels. Okay, so the pixel value you had to give to the model, and the model train it, and it should be able to find it out. So internally, what it will try to find it out. So think like a baby, just born baby was there. You want to teach the baby what is a cat and a dog. How do you do it? You bring a book. Okay, in that one book, you have the 10 images of the dog, 10 images of the dog was there, 10 images of the cats were there. Okay, so then, so each image is different. So one image is having the black cat, black dog. The other image is having puppy or pug. So German Shepherd. So different breeds of a dog was given. In the cats also you have the multiple variations of the dog. Cat is jumping, cat is under the table, black cat, brown cat, etc. So when you give this model, so feature extraction should happen. The feature extraction nothing but okay, the dog is having a tail. The dog is having a black eyes, having a four legs, and the ears, the big ears, big body. Similarly, cat is also having the four legs, some tail, some fur, and the eyes are into the different colors. So these and all we call it as the features when in respect to the images. So that feature extraction step is common for any kind of thing. Suppose if it is a text, nothing but the features are nothing but words. Okay. So once all these things were there, so then you do the feature extraction for the whatever the data you have, train the model, test the model. If it is suitable, accuracy and everything, all the metrics are good, and release the model for the production. Then after you release to the production, the model is not performing well after a couple of days or somewhere. And what you had to do, you had to come back, look at the features. Did you miss any features? Okay, add those missing features, train it again, test it again, and deploy it. Again, after doing all of this, also you are not able to achieve the good accuracy. Come back. Is there any data you're missing? Suppose your data is not having the good information about the cat, or which is the maybe hiding somewhere. Some of the features are missing. Maybe you incorporate more data. Maybe 10 images are not sufficient. Include the 20 images or 15 images. And you test against the new images. Maybe the two images are there. These are my testing images. And if this was correctly identified, then your model is correct. Okay, so that is the perception, the kind of accuracy you're looking for, that will be decided by that. So then what happened after this machine learning? So this is how in the traditional programming, what is there? You have to write the input, you have to give the input, and you have to write a program. The computer will do the computations and give you the results. But in the machine learning, it's opposite. You give the input as well as the output, and computer has to write the program. Right? Program is nothing but finding the pattern. That's the logic. That is the core logic, right? So then why you had to write a program? You had to write a program to train the model, pre-process the model. Eventually, the model is our logic. The model is our logic that can be our pattern. And after a couple of days, what happened? The deep learning has come. So deep learning, they tried to mimic the human brain. So they can they create the neural network from the scratch? Suppose we have the human neurons, right? So these neurons, so can we replicate and we call it as a artificial neurons? Okay, so we call it as a perceptron. In technology terms, we call it as a perceptron. Of course, I will be discussing more about that. So they developed this deep learning techniques because once you have the neural network and connect every neural networks in the different layers and train the same data, maybe the image data or text data or predictive data, the table data, anything. So then the results are quite phenomenal comparing with the machine learning, right? This algorithm, whatever I discussed here, may be obsolete because when you have the more amount of data, better to go with the deep learning techniques and it will perform very better. If you have the lesser amount of data, this machine learning algorithm quite better. If the data is more, go with the neural networks. If it is not, we have to go with this thing. So neural network, again, we have the multiple things. The fundamental artificial plain neural networks with only the feed forward propagation. And we have the convolutional neural network where it will deal with the images. We have the recurrent neural network where it deals with the text. Okay, so this multiple, even a lot of things were there in the neural networks architectures are keep on evolving. And this neural network architecture keep on evolving to some extent. At 2017, something happened. 2017, Google has published a paper. Google has published a paper called "Attention is All You Need." Anybody come across that paper?
I haven't read the paper, but I was aware of it.
Right. So what they have published in that? They have published a very good neural network architecture. We call it as a transformer. This transformer architecture changed everything. This is a transformer which you can see on the screen. This is the architecture of transformer. So of course, fundamentally the neural network. So, but it's like advanced neural network you can think of. It will have the encoder and decoder architecture, and this was in 2017 by the Google. So you can just go up. You can see their email IDs or the Google, right? Yeah. So then what happened? This paper was taken out, and the latter Google has published a very good model based on the transform, which we call it as the BART, bidirectional encoding representational transformer model. And 2018, OpenAI has taken this architecture and they made a GPT, generative pre-training transformer, GPT-1, back in 2018 somewhere. Then in 2019, they built a GPT-2. So you have this architecture, nothing but algorithm. You think of like algorithm. So how we have the algorithms over machine learning. Similarly, we have the algorithms like transformer. This transformer, they trained with some X amount of data in the GPT-1. In the GPT-2, they made it like 100x the data, and in GPT 3.5 in the 2021, they released the Chat GPT that we already aware of. We have been using it. That is the GPT 3.5. Okay, but that time what they have done, they have trained on entire internet, almost like petabytes of data was there. OpenAI has done this thing nobody has done before. Even the Google have not done this. So back in 2018 or 17, bot model is like our generative AI model. So once the GPT models like 3.5 has evolved, and this is like super duper hit, and it was able to generate because earlier we were only able to do the classifications or regressions, but we never tried to generate a new text out of it. That is what the advantage of transformers. Transformer made that easy. You ask a question, the model is able to reply to you with the answer, right? That is the capability of the transformers. So using the GPT 3.5, of course, it will cost a lot. So where do you train this algorithm? You have the data. Of course, the data getting is extremely tough. Whatever the OpenAI has done, we can't do it. Not a small companies cannot do it. Even mid-based companies, you should have a heavy capital to do it. Okay, so you prepare the entire internet data. You train the model, which nobody has thought about it before, and this model is having a lot of knowledge than anybody else. You ask any question, it will try to answer. Of course, it can't answer you where it was not trained on. It doesn't know your bank statement. It doesn't know your company policy documents, right? It can generically, it can say maybe the books, the articles, the videos, and all it got trained on. Later GPT-4 came, 4o, GPT-5, and later we have got the competitions, Gemini. Okay, so these and all we call it as LLMs, large language models. Why we call it as large language models? Because we trained on top of the entire the corpus of the text over the internet. Then the model becomes very huge. That's why we call it large language models. Can you tell me the top 5 or top 10, whichever you are aware of LLMs? I mentioned GPT and the Gemini. Can you think of few LLMs?
Claude.
Lord, right? And
Llama.
Luma, very good.
DeepSeek.
DeepSeek, nice. Rock.
Yeah.
Perplexity. That's
Perplexity itself is not a LLM because that will the
yeah,
orchestrator of LLMs, right? Yeah. They may
right,
have their
right.
own model. That model name you have to figure it out. Yeah. Yeah. So can you tell me how many such kind of models are there? How many? Just rough number. Do you have any rough number for this name? The large language models or something?
Would be like 15, 20.
So let me show you. Total 2,85,682 open source models are there, which you can download and run it on your own systems. Of course, GPT 3.5, 4, 4.5, GPT and Gemini models and Grok models are not the open source. Of course, recently Grok, the previous version was open source, but those are proprietary. Only the open source models are itself next generation models. You see, 2,85,682 models are there. The Quen was very powerful recently, if you didn't come across it, because here I just given a few couple of examples, but how do you know which is better? That is where the research comes into the picture. Which model is better? Do I have any dashboards? Do I have any leaderboard? I mean, so that everybody as a community, it's an open source community, right? You and me, everybody across the world, try to test these things and get some metrics, and we can evaluate all these models. Okay, that already there. So people keep on researching and trying with the different models, whatever it comes into the market, and they'll give a score that you can check. Just search for leaderboard, you will get that content. So leaderboard will have the all of these details. So yeah, so then um, just a second. This is our leaderboard. Can you look here? So every time some new model comes and they evaluate with all these metrics. So this metric will be there, which will be the Quen models and whatever the recent comes, right? Sorry, they'll try to evaluate. So coming back to our regular thing. So this is like the hundreds or thousands of things were there, these models. So we know, so if your data, you don't want to share your data with anybody else. You wanted to keep it with your own server or your own the machine. You go with open source models. Open source models never share the data because that model is running in your own computer. And if you wanted to have the, you don't want it to, okay, open source models, you had to run it in your own computer. What should be your computer specifications? What should be your computer specifications? Will it run in your regular computers or you need a supercomputer? We need a computer which can do the parallel processing heavily. So that's where the GPU concepts will come. Graphical processing units. You need a GPU computers. Okay. So if you are already gamers, you might be already having some or other gaming computer, right? Anybody's gamers here or any video creators? They must be having one of the GPU computer like RTX 3080 or 3090 or 5 series or 4 series, the 8 GB or 16 GB kind of a graphic card. So this is where the NVIDIA comes into the picture. NVIDIA is having an enormous amount of this GPUs, and these models were trained on that. So NVIDIA GPU, like initially we have the A100 GPU. This A100 GPU, you can see the cost. It will be 40 GB itself is like 10 lakhs around. But if you go with the 80 GB with the good thing, it will cost around 50 lakhs something, 40 to 50 lakhs something. If you go with the H100 machine, which is a little bit advanced to the A100 machine, this will be around 1 crore something. H200 is there recently, even B100, that will be even more costlier than whatever we have right now. So of course, this you have to understand, you can't buy it because it's super expensive. What you have to do, you have to rent it. That is the only option. Where you will rent? You will rent in AWS, Azure, or GCP, or there are multiple vendors are there outside, which are who are giving you for free, not free, sorry, giving you for lesser price. Okay, so there you can run this. So this makes you the fact that it comes with, to deploy it, you should have the server with the GPU, A100, H100 kind of a machines, or even lesser than that, based on the model size and all. Okay, so then the cost for server, maybe if you go with the A100 machine into the Azure, it will cost around $7 per hour. Okay, maybe it will keep on changing, around $6 to $7 per hour. Again, the storage cost will be separate. Even H1 also cost around same, $8 to $9 or $10 something. So that will make your the model serve capacity is like very huge. You have to have the heavy budget to do it if you are running as open source. That's where you have to go with the enterprise, where OpenAI kind of a companies or Gemini company, they will provide an API. So depending on your the count, the token count, or depending on the words you pass to the model and the response got generated, based on that they will charge. So you go with OpenAI, the chargings. If you open the platform.openai.com, and with you can see the chargings over here. GPT-5, this is the latest model, right? $1.25 per 1 million tokens. Token is nothing but 3 by 4th of the word. Think like that, equal to the one word. So technically it's a 3 by 4, but you can think of like one word is equal to one token. So you ask 1 million words to the model, it will charge you like 1.25. Suppose if it generates 1 million words as an output, it will charge you $10. Okay, if you go with the mini, it will be cheaper. So depending on your use case and the budget, you have to decide which LLM you wanted to use. All right, so depending on same thing, like Gemini also will have their own charges and all. So this will help you to reduce you don't need to have a server, just call an API and your job is done. So yeah, so that is what about this LLMs, just a brief introduction about that. And what you had to understand, what you had to know to go to this level. Okay, what kind of a jobs you can apply for, first place. So what kind of technology stock you require here? Maybe I will add the generative AI as well. You can look at the business analyst and data analyst. I'm not going to there. Data engineers, they generally have the capacity to get this data. First job is what? You have to get the data. Otherwise, you don't have the answer, right? These people will help us to get the data because they have the Hadoop or the big data technologies. So where they'll capture the logs and all the events, they'll send it back and where you have the data. And from there you can start. Okay, take the data and structure it or format it and pre-process it, extract the features and train the models. Hmm. So data scientist roles you can apply where they will apply the statistics as well as the machine learning algorithms and deep learning algorithms, try to train the models. But here, machine learning engineer role, which is equal to the software engineer with the data scientist skills. Suppose if you're already Java developer, one of you already full stack developer or something, right? So you learn something like this, you can apply for the machine learning engineer or NLP engineer kind of a roles. So as I said, so the data is spread in the tables, the text, and the images. If you wanted to work more on the images, so there you can become a computer vision developer. If you wanted to work more on the text, you can become an NLP engineer. So machine learning engineer is generally common term nowadays everybody is using. So some people extremely they will look for the NLP engineers, or some people will look for specifically for the computer vision developers. But this is generally you will see machine learning engineers slash generative AI engineers. Okay, data scientists now the positions are limited, but almost both are same. So now earlier there is a the distinction where say now there is no distinction. Even the data scientists they had to do this machine learning kind of a job. So coming back, what you had to know to get to this position. So you had to know, you had to know. So the AI. So you had to know this. Yeah. So Python first. So I hope at least fundamentals of the Python syntax you should know. So I'll be starting from the Python for AI and data science. So especially I'll be teaching the NumPy, the Pandas data visualizations, and using the some of the libraries which we have. So these are all very important to do the operations because everything is a matrix. Eventually, when you dig deeper into the models, so everything is a numbers you have to deal with. NumPy is a numerical Python, and the Pandas is where you will load the CSV or the Excel kind of a files, and in the structured format you can do the filtering, what kind of all the things, whatever you can do in the SQL, everything is possible within the Pandas. And you have to visualize the data. So then we had to use the Matplotlib or Seaborn. This is for the Python for the AI and data science. And then you have to know basics of the machine learning. So generally here, so it's not mandatory to know machine learning because nowadays this is especially for the generative AI. So I will try to give a little bit brief about that because machine learning itself is a very huge concept. That itself will take you some months to understand, and statistics you have to know and all. But at this pace, there are no much jobs for the machine learning. That's why you guys are interested in generative AI, right? So for that, what you had to know, you had to know natural language processing, how to understand the text. So we have the lexical processing, syntactical processing, and semantical processing. What is lexical processing is, so get word by word and try to understand what is it inside, and do the basic pre-processing techniques like clean up stuff, tokenization, and bag over stemming, lemmatization. So these words may be new to you. So this is like the basic processing we will do as a lexical processing. Then we had to understand the grammar of a text, which is a syntactical processing. Okay, so parts of speech or parsing, whatever we have. Next is understand the meaning of a text. We call it a semantic processing. So we have the some of thing, and we will build some of the project like building a spam detector or name entity recognition or POS tagger. Yeah, sorry. Right. So then, so you had to understand deep learning. So starting from the scratch of the neural network, like perceptron, multi-layer perceptron, feed-forward propagation, and how the model will learn in the backward propagation, activation functions, gradient descent algorithms, and RNNs. That those are our the fundamentals for the text. Then we'll go with the LSTMs and GRUs, and eventually we'll end up with the word-to-vec generation. How do we represent a word into a numbers? That is what we call to the word-to-vec or vector embeddings. Then we will go with the transformers. Whatever the paper we have, I've shown you. We will dig deeper. Entire paper, I will decode it with you. How this paper was built. So self-rendition mechanism, multi-head, position encoding. So everything I will try to dig deeper, and you will be by this transformers, you will be able to understand what is the inside of it. And then we'll take the open source GPT model, try to train with our own custom data, and so that you will get a confidence how to train a model. And then we go with the large language models where we will deal with OpenAI, Llama, Quen. So whatever we have, because we already have the servers, right? API servers were there. So where we no need to run, because I know most of you may not be having the good computers. No need to worry. We will try to deal with SLMs, small language models, where you can run inside your computer using the OLAMA kind of a tools. We can deploy it on your own computers using such kind of a thing. And we'll discuss about the prompt engineering. And then LangChain is one of the framework where we'll deal to bring the applications into the live. So production ready applications you can build using the LangChain from the Hugging Face. And yeah, so we have the LangChain is a very good ecosystem. They're having a Langsmith where you can monitor the application, Langser where you can deploy the applications. LangChain is to build it. LangGraph is where you can build agents. So there we have to go with the RAG. Building a very good RAG system is very difficult nowadays. So in that process, we'll try to build some of the projects like we'll build a PDF, the HR chatbot, where we'll deal with the PDFs, and we will build some agent which can deal with the databases, and we will deal with the search engines. And of course, so to do all of them, you need a UI. UI, I know most of you may not be having the UI knowledge like HTML, CSS, Angular, or React. So we will use the Streamlit and Gradio, these two frameworks to build the UIs. And Fast API, of course, will be there to call the REST APIs. And then, yeah, so we will do, most of them will have its own projects. So depending on this thing. So this is the entire course for the persons who are looking for the generative AI transformation. So any questions? I can take it right now because we have 10 more minutes left. So I can take any questions.
So as far as I've seen the curriculum, it's great, but how long? I mean, how long are you going to train us for the entire course?
Right. It would take around 2.5 months.
Okay, thank you.
So Ganesh, all this is good. So us being new, I mean, we do have some basic knowledge of Python, and we are not intensely knowledgeable. Uh,
Yeah. So
so-
I would ask you to just go with the syntax, how to write a for loop, how to
yeah,
like a list. That knowledge is sufficient. The for loops and while loops and then the data structures like we have the list, tuple, and dictionary and set. These four are there. Just look at these four. That's it.
okay,
Okay. So it hardly will take 4 or 5 hours for you to just get on to the track because I will be starting from the Python for the AI, right? So here
yeah,
onwards I will be starting. So better to have the syntactical. At least you should know basic syntax, the variable
yeah,
creation, and etc. Yeah.
okay. So with that said, one final question.
Hmm.
Right now, one scenario I wanna ask, right?
Yeah.
Because this is not all clear in my head yet. Uh, right now, I have a data source. right? I'm going to ingest different data sources into the a data lake or database using that data. So right now, ChatGPT, how we interact. Hey, can you generate me an performance of this server, or this? Tell me what is the correlation happened in last 1 week on this particular server if there's an outage. Can
Mhm.
we model using the data structure? We can build some.
No, what is your data? Your data is coming from the database. The database is what?
The
What is
data,
structured?
the data is coming from tools that can be a service now, that can be monitoring tools, Dynatrace, APM, Tivoli. So the plan, what we are thinking is we want to ingest all this. Again, this is a proof of concept we want to build in the company, right? Where we'll have one data source, or we're just ingesting data from the different data sources. Again, we don't know what is the efficient way of doing it.
So eventually, you have to have a context. Whatever the data you get it, extract it and pass it to the LLM to ask the question, whatever you have the doubt, right? So your goal is
Yes,
what? Your goal is to extract some, understand if there any anomalies are there in the data, or it can
yes,
be. So first of all, is it required to have the generative AI the question? Because generative is not necessary maybe, because if it is a supervised learning, when you have the input and output data, you can train a machine learning, or you can use the deep learning. But to decide whether to have the generative AI or not, that is the question of this thing.
we
Uh,
definitely want, because we want to have that, the end users should have that interaction. That's what we are looking for,
so
right?
you wanted to build a chatbot, is it so?
Something like that. Yeah.
You had to have a clear goal, what you wanted to build. Okay, then
Yeah.
if you the data is ready, you can build it, because that is only to see eventually what is happening. Maybe the whatever you're asking is an example of the RAG. Okay, you ask a question. Suppose I will give a simple question like, you have a database, and I would like to say, hey, what is the previous sales, previous quarter sales? It has to go
Yeah.
back, extract the data, and get me the previous quarter sales. That is what it will
Yes.
happen. Yeah, that can be possible. That is easy to do. That will be there in part of our course also.
And the only one challenge with that right now, if we're doing, because the companies are restricted, right? Can we download these data models into the company server where it doesn't have access to the external? The data should stay inside the network. It shouldn't go out,
So
right?
that's why I give an example, right? So in such case, you had to go with open source models, where you no need to these open source models like Llama, DeepSeek.
Yeah.
Okay, these are all open source model. You have to deploy it in your own computer so that data will be within your network.
And for Llama and DeepSeek, is there a charge for that?
No, no,
Or
it's free. It's free. You can just need to download from the Hugging Face. You just need to have a server. That's it. No need to charge.
okay, okay, awesome. Yeah, that's all I want to know. Thank you, Ganesh.
Yeah. Any other questions?
So I have a question like, is this course suits for all kind of backgrounds? I mean, the IT, or it's for developers or
So I made this
testers?
course beginner friendly. I made this course beginner friendly. So just you need to have the little bit syntax of the Python, nothing more than that. So remaining all, anybody can come across this course. No, there is no restriction. So it's like beginner to the some level I will take you. Okay. So where you will understand the in-depth knowledge of most of the things. And from there, of course, this generative is there is no full stop. So where to put a full stop to the course is always a question, right? So this is where I have taken you. From there, see, every month there is a lot of things that's happening. Nobody knows what is going to happen next month, right? So with this knowledge, you will be able to understand whatever it comes in the next. Yeah, that I can guarantee. Mm.
And how about like the practice? I mean, I know you
So
you
I'll be giving you assignments. So if you're
yeah.
able to do the assignment, that would be really good. Most of the concepts will have its own assignments. I'll be asking you some self-assessment question within the class itself. Every concept will have its own self-assessment. So I would ask you giving the multiple choice questions, or I will give you the assignments I'll publish into the Google Drive. So everybody has to take that problem and solve it in your free time and submit it back. Yeah,
One question, I mean, do you need to have any statistics background or anything to understand this
not required.
models?
This is not a data science class, because if it is a data science and machine learning, so
Okay.
that course is different. I used it to offer earlier. Now I stopped it because many people are not taking that course. Most of the people are going to generative AI, right? So last year, till last year, I was teaching that. That there I will be teaching statistics from scratch. Statistics,
Oh.
hypothesis testing, and everything, machine learning. That was like 3 months, 2.5 to 3 months. That course was. But now I made this course. Whoever very freshly they wanted to jump into generative AI, whatever is required for them. So those things I will be teaching.
Oh, thank
Yeah. So yeah. Anyway, this session is recorded. You can ask your coordinator who sent you that. They will send you whoever joined lately. They can go back and watch the recording from the beginning.
Ganesh, just one question. So, is there any batch for you currently related to data science?
No, actually, there is no data science batch. Earlier, so many batches were done, but there are no people much interested in right now in the data science. That's why I didn't take it. Currently, 3 batches are going on. All 3 of them are generative AI.
Okay.
Yeah.
Okay.
Are you interested in data science or what?
Yeah, basically, yes, correct.
I think you are okay, huh? Yeah, because it's okay because I'm not recommending because it's good to have data science, but there are no recruitment based on the data science. Earlier, statistics is a very good concept. General statistics is a very hard, to be honest. But nowadays, no recruitment much. You will see nobody will ask you the data science related questions like statistics and all. Most of the people mainly focus on these kind of areas. Everybody wants something to be shipped immediately, right? Yeah.
Okay.
It's always good to
Okay.
have, but yeah. So if you come the previous year or 2 years back, I would have told you. So that is a good question. Why? Because it's to learn the AI is it 1 month generally not sufficient, right? So I had to curate in such a way. I myself learned for more than 2 years. I went to the Triple IT and then I went to the masters into the NLP and I published a thesis and I came back and I having multiple projects shipped and all. That took me a lot of time because nowadays like people don't have those many years of time to learn. If you wanted to go that process, it would take eventually at least 1 to 2 years minimum. So I had to curate so in such a way that people can get jobs very easily and in less time. All right, so I think we'll stop it here. So any other questions do you have? I guess I answered most of them. Right? Yeah.
So these
Every day,
classes will be once a week or
every day it will be 1 hour, so maybe same time.
okay.
What time usually it starts?
Same time, whatever you join, right? Same time. It's 8 to 9 p.m. Yeah. I'm from India, so I'm talking in the Indian time.
Understood.
Yes,
Thank you.
anyway, so yeah, so I hope you got the good information. All right, so if any questions, you can ask your coordinator and they'll approach me. Then, or I can even clarify your doubts if you have anything further. All right, guys, so thank you. Thank you, everyone. Have a nice day.
you.
Bye.
One last question. Is this the only time or do you have any other time slots? Or
Oh, the thing is, all 3 batches are full right now. So
oh,
even now,
oh,
9 to 10, there is another batch is going. Maybe if that batch is one of batch, maybe in 2, 3 weeks it will be getting completed. Maybe then I can give you flexibility to move. Maybe times I can move, and especially
oh,
this time. So, but 2, 3 weeks, maybe by this time, maybe by the time you guys join and decide, maybe it will be 1 week. So maybe after that, maybe 2 more weeks or somewhere. So the other batches get finished. Maybe then I will give you flexibility to move the class. But for some days, try to adjust because this is a morning time for you. I know. By the
yeah.
time we complete the Python for data science, then I will give you some flexibility to change the here and there time. Okay.
Sure. Thank
Yeah. Thank you. Thank you, everyone. Have a nice day. Bye.
Thank you.